Hi and welcome back, and today we're going to be doing the copper plating that I promised you, and we'll be doing it in the electronics workshop for that. Okay, and they've already seen the kit that I used in the first video, and we'll be using the activator which I made in the last video. Okay, now I'll take you around first. Right, so this is the electronic engineering workshop. Okay, this is where we make all of our electronic pieces of custom made test equipment, all the mechanical components for it. Okay, so things like jig stands, holders, guides, I don't know, you name it, we can do it here. We've even done, you can modify a few engine blocks for an external company in here. So there we go. But what we're going to be using, okay, is let's get over here, is our activator which we made up. We'll be plating this board, this little test board which you've already seen with the holes in it. We'll be plating this one, testing our solution, plating holes in our plating tank over here. Okay, so what we do first is clean up this board. Okay, make sure it's nice and clean, nice and shiny. Get all the oxidation off it, get all the dirt off it, and to do that you use a piece of emery cloth. So let's get started. Right then, so first thing you do is clean up this board. This is emery cloth. You can either use emery or flint paper or whatever you want. Don't use sandpaper because you tend to get a lot of salt in sandpaper and it will knacker up your plating. Okay, so actually, before I do that, okay, over here I've got my reflow oven. Okay, it's mainly used for soldering, but it's really useful because it's got a temperature profile on it. Okay, you can set your different temperatures for different times and so on. So it's really good for curing off your PCB activator. Okay, makes life a hell of a lot simpler. So kick that off first. You want to heat it, preheat your oven to about 125, 128 degrees. Okay, first of all. So while that's heating up, we'll prep the board. Right, there we go, all cleaned up, nice and shiny, got rid of all the crap off it. You notice I'm wearing gloves, okay, very important. Your hands contain a lot, on your hands you've got a lot of grease, a lot of acid, a lot of salt. Keep it off the board, otherwise when you plate it you will end up with fingerprints. You'll have your fingerprints plated in copper on here, okay, and you'll be immortalised for posterity. Right, once this is done, this is ready to be finish cleaning up, and then we can dump it in our activator. So okay, grab some tissue, board, and we'll go to the other side. Right, so then lid off of that activator. Done. Take your board, you want to gently submerge this so it's just under the surface. Hold it there for a few seconds, tap it on the side a little bit, and then slowly draw it up. Okay, and what you'll see is this, as you can see, I don't know if you can see that clearly, but you can got some coloration. You've got your blue solution on the surface. Okay, it's gone through the holes. Okay, you've got a colour change around the holes. That means that it's actually flowed through the holes. And you just want to just pull off the excess, just twist it left and right. Don't hold your fingers on the actual board surface itself, otherwise you end up with fingerprints all over your board even though they're in gloves. Okay, and there we go. So that's what it looks like. It's pulled in the holes, if you can see that clearly. Okay, and this goes into our oven. When you put it in here, always make sure that you put it on 2 little stands, okay, so the bottom of the board isn't touching the bars or anything. That can go in, gloves off, and we cure off the board. Okay. And start. Down curing off the board about 128 degrees. That takes about 12 to 13 minutes. I'll do it for about 12 and a half seconds, 12 and a half minutes. After that, you've got to whack up the temperature to about 175 in this particular oven. Okay, temperature slightly higher, so I have to set it slightly higher, up to 178 degrees. Okay, again, cure it off. I think it's for about 7 or 8 minutes, I think it is. So I'll have to check on that and I'll let you know in a moment. Up here, there you can see my timer ticking away there. Temperature oscillating around 128. Okay, and inside, I don't know if you can see this too clearly. Okay, I've got my board there and it's slowly curing away in the oven. Here's a oven. The reason why the light's flashing, it's a halogen PCB reflow oven. Okay, it's a halogen lamp inside there and it's pulsing away because it's oscillating around temperature. Okay, to try and keep a good temperature in the oven. So we'll let that go and we'll be back later on. Was 8 minutes, I was right. So 8 minutes up to 178 degrees. It's just blasted the oven up to that temperature. And take a look. Can you see that? Now the board is changed in colour now. It's a nice dark black colour. It has got a tint of pinkish to it. I don't know if you can see that on the camera. Very difficult to see because it's quite bright in the oven. So yeah. And time's almost up, a few seconds. There it is in there. Time's done. Oven switched off. It's cooling down, so out it comes. Okay, there we have it. Okay, this is what your board looks like after it's been activated. Okay, you can see, I don't know if you can see that, a pinkish gleam to the activator and the light. Okay, that's where it started metallising. Okay, see that sort there. That's a bit too dark, that one. Right now. So, no gloves, so gloves back on. And what we've got to do is to clean this board. Okay, and a little bit of soap and water is all that you need. And we're going to do that now. Okay, back again. Let's put this out on a bench so you can see this a little bit clearer. Okay, I don't know if you can see that in the light here. The light's not that good, so I'll move this under the light. So, yeah, there we go. Definitely see a pinkish sheen to that. It's not completely black. Okay, and we'll wash this off. You can just use try and use oil-free soap, or something that hasn't got much crap in it. If you need to use a bit of soap, and yeah, just give it a gentle clean. nothing vigorous. This is the board all cleaned up now, and in actual fact I didn't have to use any soap on this at all. Okay, you can still see a lot of some of the residue on the surface of the board, but it doesn't really matter too much if you have some of that on there. Okay, because this is actually slightly conductive, this solution, this activator is, and it's through the holes and you're going to be playing on top of it anyway, so it doesn't matter if there's a little bit left. Okay, and if we look at the light, okay, you can actually see through the holes, they're all clear. Okay, you can see that. Lovely. If your holes aren't clear, make sure that they are. Just blow an air duster through them just to clear them out in case there's any activator still in the holes. Okay, that may have queued up and blocked them up, so just wash it down, dry it off with a paper towel and blow the holes and you're done. Next stage is to pull it in this tank, so there we go. Right then, yeah, so we're going to be putting it in here, so make sure that you do glove yourself up, okay, because this stuff will eat your flesh. And so, all gloved up, nice thick gloves. The lid comes off our plating tank, and what we do is clamp this board, okay, into our bar in the centre, okay. So can't really do that with the. I need more hands. So first thing to do, wash this back and forwards in the electrolyte. Okay. This fills the holes with electrolyte and it knocks out any air in the holes, because you don't want any air in the holes. Open up clamp. Okay, you can get tanks or you do it yourself kits that use hooks or clips and stuff. Some of them use crocodile, some use hooks. They don't work too well because you don't get an even surface current developed across the board, because you're only clamping the board in one or two places, usually the corners. Okay, and it gets clamped into there. Make sure that your holes are under the surface, and that's the reason why all my holes are on one side of the board, because I've left one section to clamp it above the electrolyte. Okay, and I've got all my holes and the rest of the board is submerged. The submerged area is what gets plated. So, gloves off, and okay, there it is. You can see my board there. It's clamped into the top of the bar. Two copper plates. I'll be passing the current through the electrolyte. Okay, why two copper plates? It's because it's a double-sided board. If there's one copper plate, I'll get too much copper building up on one side of my board and hardly any on the opposite side, so it gives it even plating. And yeah, make sure that these copper panels are larger than what you're actually plating to, so the power transfer is even. okay, just like in the capacitor. Okay, you've got two plates, anode and cathode, charges separate out, same sort of principle is the same. Okay, if your circuit board is larger than your copper plates, it's not going to plate particularly well. If it's smaller than the plates, then it will. So that's all in there. Close up the lid, and we set our kit. Now that board is it's 5 inches by 1 inch, so that means that I need surface current of about 1 amp. Alright, switch this on. I'll switch the timer on. This should only take about half hour to actually plate a board. Okay, it's a lot quicker to use this than it is the ink, so I'll set the timer. Whack up the current to about 1 amp. There we go, and it starts plating. Okay, so just lift up the corner here so you can actually see what's going on here. There it is, it's on the go. Okay, got my bubbler mixing up my solution. The actual bubbler is blowing bubbles on the surface of the board. That's to actually knock out any air pockets that slowly develop in the holes. So as the electrolyte sits in the holes, it gets used up. More electrolyte has to flow in because that's what plates your holes. If you don't knock out the air holes in your board, okay, due to the gases, because basically you're splitting the solution, okay, just like you know, split water to get oxygen and hydrogen. Okay, this is the same principle. You get gases coming off this, and they will build up in the holes as the solution is used up in the holes, plating. And if you don't knock out the air bubbles, then obviously no solution passes through the holes and no plating takes place. So I'm going to do this for about 20 minutes, half hour, and I'll show you the results. Okay. So remember, the longer you plate, the thicker your board gets, and you do have to work out your surface current for the board that you're using. That's dependent on the size and the thickness you want to aim towards. Okay, so as well as dependent on the hole size as well. And I'll take you through that in the office while this is plating. So a quick recap on the stuff. Okay, one thing I have to say first. Okay, you are dealing with chemicals, so make sure that you wash your hands. Okay. Whenever you're finished doing the processing, okay, whatever processing stage you do, and you go away, you're not going to be doing anything, make sure that you wash your hands. Yes, you are using gloves, but gloves aren't waterproof. Okay, if you do get a split, you do get a tear, you do get a punch or anything like that, you can get your chemicals on your hands. Maybe it's so small that you don't notice it, but you do get a bit on your hands. It may even drip down the back of your gloves. Okay, so always wash off your hands. Okay, especially if you're going to be eating or drinking. Whatever you do, don't eat or drink around that area. So from the top, preparing your board. Okay, so and plating it, you have to clean your board, scrub it back, give it a wipe over with a cleaner. Okay, remove any dust and debris. Next up, into the activator. Okay, dip it in slowly. Okay, flush to the solution, so surface to surface down. Okay, slowly submerge it for a second or two. Slowly raise it. Okay, take a look at your holes. Make sure that you do get that colour change around the holes. Okay, if you don't, okay, resubmerge, bring it back to the top. If it still doesn't happen, okay, wash your board, clean out your holes, try it again. Okay, if it doesn't, if you don't get that colour change around the holes, that means that it's not being drawn through the holes when you raise it out the solution. Okay, your activator isn't flowing through the holes. So it's really important, that is. The only time when it doesn't happen is you've got particularly dirty holes, or the cut to the hole is particularly rough. Always hold the board at the edges, okay, from the surface when you're putting it in. Once it's out, rotate the board a few times, get rid of any of the surface solution. You need a bit on the surface, but you know, not tons of it, so just let it drain off back into the dish, lid back on, and put it in the oven. Okay, put the board in the oven. Make sure it's raised off the bars. Okay, so the bottom of the board cures as well as the top. And you do 2 cycles in the oven, okay, one straight after the other, okay, don't let it sit or anything like that, and timing is critical as well as temperature. So about 125, 128 degrees for about 12 to 13 minutes, 175 to about 178, 180 for about 8 minutes, okay. Obviously depends on what oven you do it in, okay, and if you've got hot spots in the oven and things like that, your temperatures will vary slightly, okay. So if your board doesn't come out like it did in the video, make sure that you do play around with your temperatures. It may be slightly too hot, it may be slightly too cold. Sometimes it might be better off to put a thermal cup or something like that in the oven, temperature probe, so you can actually monitor the actual temperature, which is around where you placed your board, so you know whether or not it's got to be higher or lower. Yeah, after it's out of the oven, clean it off. Okay, I just use water in this video, just for that, just running water. Okay, just wiped over the surface of the board. If it's particularly baked on hard, then you might want to use a little bit of soap. Okay, nothing abrasive. Okay, because you want to be very gentle with your holes. Okay. Metallization layer is very, very thin. Okay, yes, it can take a bit of a battering, but don't go at it hammer and tongs. I just used a bit of water and used my fingers just to wipe over the board. You can use a sponge if you want to go that little bit on, but not a particularly aggressive one. Okay, washing up the sponge, not the scratchy side, just the sponge side. After it's cleaned up, dab it off. Okay, you inspect your holes, make sure they're clear. If they're not, air duster, blow through the holes. If they are clear, brilliant. Move on to putting it into your plating tank. Now remember, generally one side of your board is longer than all the others surrounding edges. Okay, this is to clamp it in the cathode bar. Okay, which your board is effectively the cathode, your copper plates on either side, your anodes. Get them around the wrong way, you reverse plate, and you'll be taking your copper off your PCB. Okay, so make sure that you do get them around the right way. Yep, that end is very, very important because your cathode bar has to be above your solution. Okay, generally by a few centimeters. There are other methods. Okay, some boards that don't have a plating bar, some boards have a hook that goes through 2 mounting holes that you have to pre-drill into your board, and that drops into your solution. You take it out and there you go, your hooks are actually plated into your holes along with everything else, and you've got to break them out, cut them out. This is not particularly a nice way. That method with a bar or a clip or something above the solution is the best way to go. Okay, and it also gives you that extra piece of material to hold the board when you're actually putting it into the electrolyte. When you put your board into your plating tank, make sure that you do swish it about with your liquid. Get that activator into the holes. Important. Once that's done, it's in the bar, top on, lid on. Okay, your current supply goes on. Okay, now that board, it was 1 amp. It was 1 inch by about 5 inches, which roughly works out to be about 1 amp with an AFSF around 15. 15, I can't remember, was it 20? I can't remember what I bloody set it to, what I chose now. And it works out to be about 1 amp. Okay, now then, the way how you work out how much current that you need, okay, is this. I will get my whiteboard for this. It is the length of your board in inches. This is all in inches, okay? The length of your board multiplied by the width of your board multiplied by 2, because there's 2 sides. Okay, that's what you need to do first. That works out your area. Next, you divide that by, okay, divide that by 1, 4. Okay, then you multiply it. No, you do multiply it. And you multiply it all by your ASF. This stands for your amps per square foot. Okay. And usually this is the thing that varies dependent on your hole size. Okay, usually you set this to about an ASF of about 15. That covers small holes to very large holes. Okay, because generally PCBs have multiple, there's tons of holes in it, all different sizes. All your component leads to different sizes. You've got mounting holes, you've got vias, you've got through holes for components, stuff like that. You know, what do you choose? Okay, if it's set to too high, okay, if it's set to say 25 or something like that, or 20, there's a good chance that you can seal up your your small holes. Okay, and if you set it to a very low value, there's a good chance that you won't actually plate your small holes. Okay, so you have to try and do a rule of thumb. Okay, low ASF for large holes, for small holes, high ASF for very large holes. But so you have to try and do a compromise, and roughly about an ASF of 15 is about right. Okay, and this will equal your amps that you have to set up for your board. Okay, that's what you set. So the formula is this. I'm going to scrub this back. Okay, we'll do it this way up. It is length times width times 2 brackets. Okay, divided by 144. Okay, all bracketed, multiplied by your ASF, which is generally about 15, and that gives you your current. Okay, which you have to set. Okay, and that's the current that you use to plate with. Okay, very important to keep hold of that current. Now, how long do you plate your board for? Okay, that's the next one. I'm doing my one for about half hour. Okay, you don't have to. This is the actual maximum plating time. Okay, but your board might plate a lot quicker, depending on what activator you use. If you've got an activator like what I've done, okay, you will metallize in copper. Okay, so you actually run a little, nano layer of copper in your holes and things like that. So plating is a lot quicker because you've already got that copper layer there, so it plates it a lot easier. Okay, unlike your inks and stuff like that. This formula was actually developed for inking. Okay, because that's what came first. Okay, before we had that, and in order to work out your time, it's quite simply, it's the it's the thickness that you want to plate to, okay, in mils. So say 0.65, okay, mil. That multiplied by 1080, okay, divided by the ASF that you chose for your current, okay, which is generally at about 15. But this gives you your time. Okay, that gives you your time in minutes. Okay, done. So in my case, what I've gone for, okay, so I'm going to say I want 0.65 mil in my holes, multiplied by 180, okay, divided by 15. This works out to be, I don't know, roughly, off the top of my head, I'm not even going to work that out, it's going to probably be about half hour. Okay, half hour, 45 minutes, something like that. Okay, it's not a particularly accurate one for time, like I said. It all depends on your activator, depends on how well your solution is mixed, okay, how much copper sulfate you got in your electrolyte, how clean it is, how good your plates are, okay. If your anode plates are breaking down, okay, you haven't got much copper there, it's going to affect your plating time, okay. This is just a basic, okay, rule to go by, okay, but check it out, it can take longer, it can be quicker, it can be longer, it's a grey area, okay, and plating is a very, very black art, okay. If you do decide to do plating, it's a black art. There is a lot of tinkering to do it, there's lots of tampering that you need to do with solutions, there's lots of tempering that you need to do with your working out your times, but generally you'll get an idea of, say, yeah, okay, I want to plate my board, yeah, okay, alright, good enough. After 3 or 4 attempts you say to yourself, yeah, it takes half hour in the tank, brilliant. Why do I need to work out time for? I know that my boards only take half hour. So, because it's not based on the dimensions of your board, because your anode plates are larger than your board, therefore your power transfer, okay, it's going to be equal, okay. Obviously, if your anode is smaller than your board, okay, you're shafted, okay, you're going to have to plate for longer, okay, and your plating is going to be uneven. So it's always best to go with your anodes a lot bigger. Done. Right then, that's been about, what, 15 minutes now. I'm going to give it, let's give it 10 minutes more, and I'll go check on to see how the board's going. Back in a moment. Right, it's been about 20 minutes, okay, not exactly half hour, but good enough to show you what's happened in the process, okay. So, as you can see, if I angle this slightly, you can see my holes now have, you can see it on the large ones more clearly, but they are plated. Okay, now, as you can see around the edge, okay, there's a discoloration, okay, this one's matte, this is quite glossy. Reason for that is, okay, it's because I'm running out of copper bright in my electrolyte solution. Okay, copper brightener is an additive that you add to your electrolyte, okay, and it improves plating performance, okay, it evens out the plating and it stops your boards from getting dull. Now, even though it's dull, doesn't mean it's crap. It isn't, it's perfectly fine. It's copper, it's just that it's matte finish, no biggie, okay. It may not look as nice as the polished up copper, but it still does the job. It's still soldered to it, it's still electrically connected, it's still got the same impedance, you know, there's not really much difference in it. Okay, and also, as you can see, the edges are also plated. There we go. Okay, even though they are roughly cut, okay, they are all nice and plated as well. Brilliant. Now you can do edge plating with that solution as well. Edge plating can be slightly more difficult because you do have to hold the edge of the board with your fingers, and when you put it into the solution, sometimes you end up with a patch which you know, doesn't get as much solution on it, and it doesn't plate because you haven't got your activator in that area. Or the edges of your board are too rough, okay, you may have guillotined it or something like that, you may have been chopped with a hacksaw, you know, you may even bloody run a scalpel down it and snap the board, okay, to get it to the size that you want, okay. It doesn't always work because the finish is pretty poor, okay, but as you can see, this finish, okay, this is on a poor, roughly cut edge. This was guillotined and it was hacksaw down that end, it was guillotined off either side, and yeah, it's doing perfectly fine, no worries, okay. Just like I said, okay, that copper bright does solve that problem. So if your solutions are, if your balls are coming out dull out of your electrolyte, you can get copper bright. It's available on all from any PCB house. It comes under various different names. The one I use is from T-Tech. It's where I got my plating kit from, okay. They sell it there in I think what size is it? I think 500 millilitres or 250 millilitre bottles, and you just pour in a slight amount. It's a slight impurity that you add, and it varies. So the reason why is it's not put in plating solutions, okay, because they don't know what finish you want, okay. This copper electrolyte may go off into the jewellery industry, okay. They may want a matte finish on some of their items. It may, I don't know, it may go up to the PCB industry, electronics, where we like it nice and shiny because it's nice and visible, but perfectly honest, it doesn't make the blindest bit of difference. So there we have it, perfectly done, okay, quicker than what it said on the tin, okay. If you want your holes a little bit thicker, okay, just leave it in the tank that little bit longer, thicken it up, and there you go, it's all done. Yeah, try and get it, there we go, you can see it nice and clearly there, okay, and the edge of the ball, it's slightly missing a few bits on this side. As you can see, the other edges are done except for where I held onto the board, okay. And if you can see just around this area here, okay, I don't know if it's slightly visible, you can maybe just make out my glove imprint, okay, so be very careful, okay. I did accidentally grip hold of the board up here when I was putting it in the tank. Wasn't paying attention to which end I picked the board up by, and and also left, as you can see in that top hand corner, my fingerprint. Okay, you can immortalise yourself in copper if you're not too careful. That's why you make sure that you do wear gloves. If you wear gloves, okay, you get that sort of imprint. It's nice and shiny. It's still connected perfectly fine. That way up. If you're holding onto your board for a very long time without any gloves on, okay, you can affect your plating. Okay, skin does contain acid, it contains salts, it contains grease. It will oxidise your copper on contact. Okay, I've just been holding this for a few seconds. As you can see, it's getting all tarnished and crappy up one end. It's still perfect fine while I haven't been holding it out of the tank, in the tank. You know, that's only 20 minutes. It definitely does make a difference, okay? Work on your boards as quick as possible. Don't handle them unless you absolutely have to, okay? And you especially don't want to handle them where you're plating, where your circuits are going. Otherwise you can be immortalised for life in your work, or your plating will fail. So there we have it. Any questions? Yeah, just whack them down as usual. Okay, and see you next time.